In pro
Good morning, this is your Stats Sensei, Mr. Spensei, and this is an introduction to AP Statistics. This video is just designed to introduce you to the course. The other videos will be actual lessons. So first off, welcome to AP Statistics, and I'm glad you joined in. And I need to let you know that for those of you who thought you were signing up for a math class, it's kind of important to let you know I consider it a stats class. It's not really a math class. It's more like saying that science uses math. Well, in statistics, we use math and we teach you to reason, but it's not really a math class, although you're likely to get math credit for it. And like science, we test hypotheses and we design and complete observational studies and experiments. So there's some science to it, but it's really its own separate thing. So if it's not really a math class, then why is it and what is it and why should I care? Well, first I'll address why is it important? And really it's important because I said it is. And I'm sure that answer didn't satisfy many of you or any of you, just like when your parents tells you the same thing. So how about this? I'm going to tell you that statistics is extraordinarily powerful and it's everywhere. For instance, how do you think Amazon grew to be so huge and powerful when it started off as just an online bookstore? And now you can buy just about anything there. The answer lies in their use of statistics. How do you think that Japan became a major manufacturing power known for its high quality automobiles when their country and industry was virtually destroyed by a world war? The answer is statistics. How do you think a baseball team with the lowest salary base became divisional champions? The answer lies in statistics. How did a group of MIT nerds get banned from Las Vegas for winning too much? The answer is statistics. Oh, I kind of got your attention now. How was an effective HIV screening test created from one that was completely unreliable? And the answer is statistics. So right now you see that it's in showing up everywhere. It's in manufacture, it's in medicine, it's in advertisements. Matter of fact, how do the advertisements selected from your computer screen or your smartphone? The answer is statistics. In fact, how did Target know that a teenage girl that they had never seen was pregnant before her father did? And the answer is statistics. It's almost scary, isn't it? So let's explore this story about Target a little bit and the teenage pregnancy a little in more detail. The background. To make better use of their advertising budget, Target began utilizing statistics to better identify the purchasing patterns of their customers so they could send advertisement that might be greater interest to each of their customers. Now, this is the back when they actually mailed advertisements. They weren't sending it to them on the smartphones or emails, and which they do now, but they were still mailing things. So what they did was based on what a person purchased, they would send advertising coupons to that person's home, predicting that the customer might want to purchase some of those things. To that end, a teenage girl was receiving advertisements for baby items. Father became extremely angry and called out Target outside of Minneapolis, demanding to talk to the manager. And he kept saying, my daughter got this in the mail and got this advertisement in the mail, and they're all for baby cribs and baby clothes and diapers and wipes. Are you trying to encourage her to get pregnant? She's only a teenager. Of course, the poor manager had no idea what the man was talking about. And he looked at the mailer and he said, sure enough, it was addressed to the man's daughter and contained advertisements for maternity clothing, nursery furniture, etc. The manager apologized and and then called a few days later to apologize again, not knowing what else to do. Surprisingly, on that phone call, the father was somewhat subdued. And he said, I had a talk with my daughter. And it turns out there's some activities in my house that I haven't been completely aware of. She's due in August. Basically, based on the things that she had been looking at on the computer, because this was before the smartphones, they knew or suspected the person they were talking to was pregnant. They had no idea that it was a teenage girl at the time. If you're interested in more of that information on those articles, you can go to these links here and they have them, all right? And they're available to you. So now that you're a little curious, let's answer the question that you originally asked, which was, what is statistics? Because you said it's not a math class, so what is it? Well, statistics is the study of how to collect, organize, display, describe, and analyze data from a sample. This is a key phrase, from a sample in order to make generalizations about a population. And I know you're sitting there going, oh, great. Here this guy is giving me a definition, thinking that it explains everything, but in reality, he just created more questions than answer. To which I must respond, that's probably fair enough, but give me a few more minutes and I believe I'll be able to break down the definition and give you an overview of what the course is at the same time. First off, my AP Statistics course is divided into 4 sections. First section is collecting data, and we'll have a free response and multiple choice tests on that section. The next is describing data, and that's displaying and describing the data we just collected. And we'll also have 1 free response and 1 multiple choice section on that one. The next section is analyzing the collected data, which is probability. We'll have 2 free responses and 2 multiple choice tests there. And the final section is making inferences or decisions, which I consider the most powerful part of statistics and the true part and most exciting part. And we'll have 3 free responses and 3 multiple choice tests on that section. I have to say that section 1, unit 1, collecting data, and unit 2, displaying and describing data, will probably finish during the first 9 weeks. Probability will take us almost the entire second quarter. And for many students, it's the most challenging. 25% of my students will absolutely love it. 75% will think it's the worst thing ever. And then it almost all comes together for everybody when because most really enjoy this next section, which takes up the entire third quarter and will run very little bit into the fourth quarter. I have to say that the first 2 sections are probably the easiest sections of the course. And it's kind of imperative that you achieve good grades for those of you who might struggle on the probability section. The other thing is you need to actually study really hard for those 2 sections, because even though it's an easier section, it's different than what they've ever done before. All right. And like I said, probability students tend to struggle a bit with, and then they move into inferences, which is everyone's favorites. And it's because that's where the money is. That's where we get to make decisions based on data. Should we purchase a new machine? Is the new drug more effective than the old one? What can we predict with this, and how confident are we? As I've indicated already, I love the section on inferences, and I feel it's empowering because it's from this section that I can use all of the collected data to make an informed decision and not just a guess. Now, I want to be perfectly clear about the word guess. Nothing in statistics is certain. However, with statistics, I'm able to determine the chance that I could be wrong. Typically, I will choose to be correct about 95% of the time, which means I accept the chance that I will be wrong about 5% of the time. But I'm getting ahead of myself, as these discussions will occur in detail in the third quarter. As we begin the course, I should warn you that there are a significant number of definitions that must be learned in order to understand what we are trying to accomplish. So how important are the definitions? I'm going to say extraordinarily important. Put it this way, I don't expect there to be any mathematical calculations on your first exam. That isn't to say the first exam is easy. It's just a recognition that statistics is different from all the other math classes you've ever taken. Incidentally, the first test is often challenging for students, not because the topics are difficult, but because you're being asked to think and write and reason in a manner that you haven't done before. In previous math classes, you followed an explicit set of directions to find a solution to a problem. In statistics, you'll be expected to not only know and apply the definitions and methods, but be able to relate them to the outside world. In fact, the more you know about the outside world and other subjects, the more connections you will be able to make and the more successful you'll be in this course, and the easier the course will be, even though you're talking about things that don't specifically relate to the topic that we're working on. It's tangential. So back to the definition and why we need statistics. As we said, statistics is the study of how to collect, organize, and display, describe, and analyze data from our sample in order to make generalizations about the population. So notice, so we already say we're going to collect and organize, collect it. So we're going to, which is our unit 1. We're going to organize, display, and describe, which is unit 2. We're going to analyze, that's unit 3. And then we're going to make generalizations about a population and decisions, and that's unit 4. So to fully understand what that definition means, we need to understand the concept and importance of both the population and the sample. Population is purely the entire group of interest. In an election year in the United States for a presidential election, the entire population would be the vote, those 18 and older who are going to vote in the presidential election. If it's a governor's race, it'd be those 18 and years older who are going to vote in that state. So it depends, a population is just the group of interest that we want to know something about. A parameter is just a measurement of the population. It's the true measurement of the population. It could be the percent of the people voting for that particular candidate. A sample, on the other hand, is a subset or small part of a population. It's not the entire group. In fact, I like to say this. If you were looking out the back window of the car, you turned your head around and look out the back window of the car, you'd have a full view of whatever was back there. That would be your population of interest. A sample, and particularly a good sample, will look like that. And that's what the rear view mirror in the car gives you. It gives you a smaller version of what you're looking out the back window. So in other words, it's a subset or a small portion of the population. Now, a statistic is a measure from the sample. So a statistic comes from the sample. It's the measure of the sample. And a population, the measurement is a parameter. Notice population and parameter both starts with P, and sample and statistics both start with S. Please keep that in mind. Do not switch these terms, all right? So, because we can have the population average, we can have the sample average. The population average would be the true population. That'd be a population parameter. That average would be the average of the entire population. The sample average would be a statistic because it would be coming from the sample and would not include everybody in the population. In statistics, a population is the entire group of subjects or individuals that the subject is interested in, while a sample is just a subset of that population. We may be interested in the percentage of students in your statistics class that have brown eyes. In that case, our population would be the students in your statistics class. And of course, it'd be fairly easy to count and figure out the percentage of brown-eyed students in the class. The percentage of brown-eyed students in the class would be a parameter because we would have counted everyone. Because we are checking the eye color of the entire population, every student in the classroom, we are conducting a census. And that's just when we count everybody, like they do every 10 years in the United States. The census is a counting of every individual. The problem with the census, and by the way, if you conduct a census, you know the true population parameter. If you're able to do a census, there really isn't any need for statistics because there's no need for estimation and no need for conducting statistical tests. But it's often difficult, if not impossible, with a large population. What if I wanted to know the percentage of people in the state of Texas with brown eyes? Well, there's no way I'd be able to count every brown-eyed person. Matter of fact, new ones are being added every minute and others are passing away every minute. So that percentage is going to change slightly and I just wouldn't be able to count everybody. The other thing about census is it becomes very, very difficult to do on certain things. Is just completely impossible. Once again, if I was talking about the students at my high school, I could do that. But as soon as I move to the city, it'd be almost impossible. In the state, less possible. In the world, unrealistic. In fact, when the U.S. conducts a census, it's often very flawed. Another type of census that'd be difficult is if we want to know like the average size of bass in a particular lake. Well, without draining the lake, we couldn't do that. And if we drained the lake, there'd be no bass at all, in which case there'd be no lake and there'd be really no point. Another thing is I couldn't count all the red blood cells in your body without removing all the blood from your body and sucking your life away. Of course, maybe I'm going to do that with the stats class anyway. As I said, census can be extremely difficult to do and expensive. In 2010, the census cost $13 billion, which means it costs $42 for every single person. And that to me seems like a lot when you're just asking a person a couple questions. And due to the difficulty of execution, the census can be very inaccurate. In fact, in 2000, the census, it was estimated 6.4 million people were missed. Now, this was an estimate. So that means 6.4 million people were not counted. However, they estimate that they had an overcount of 36,000. You're like, what? That doesn't make sense. Yes, that means that they actually counted some people twice. So some people got counted twice, and about 6.4 million Americans were not counted at all. So you can see that there's an accuracy error, even though we're spending $13 billion on it. In Hidalgo County in 2010, 225,000 people were missed. So while a census is great, it's not always doable. And when we can't count everyone, we need to introduce statistics. In the next video, we're going to run a simulation that covers all 4 units. And so basically, in the next video, we'll cover all 4 units of the course in one video. All right, hope to see you on the next one. Thank you for watching this one.